Okay, let's move towards question number 3, which says that the diagram shows a closed cubicle container of made up of a thin elastic material, which is filled with water and frozen. During the freezing process, the length x centimeters, so the length of this cube, you would say, is x, and then the volume of this cube is v, right? And the rate of increase of the length, right? The rate of increase of the length is basically 0.0 centimeter per minute. Okay. The volume is this at t minutes, which is v, and find the rate of increase of v, right? So what is the volume of a cube? What's the formula for a volume of a cube? That is, so if you're talking about talking here, so volume of this particular cube would be x cube, right? Now we know that dx over dt, right? The rate of change of x over time is 0.01 centimeter per minute. And we have to find dv over dt, right? That is the rate of change of v over time. Now, what we can do here is we can apply the chain rule. So the chain rule is basically, if we have dv over dx, right? And if we have dx over dt. So this will eventually cancel out, right? These dx and dx. So we would be left with this dv and this dt. So, and that's exactly what we want. So that's how we calculate it. And so for that, we need dx over dt. We're already given that in the question, but we're not given dv over dx, right? And for that, we have to differentiate. So dv over dx would be found after differentiating. So if we differentiate x cubed, that would be 3x squared, right? Right. So we decrease one from the power for differentiating. Now, in order to find dv over dx at the point where x is 20, we can just substitute the value of x as 20, and then this would be 4. Okay, so 400 times 3, which is 1200. So our dv over dx is 1200. Now we have to find this, right? We have to find this. So yeah. Okay, so for finding this dv over dt, we know that at dv over dx, we just found that it's 1200, and we already know dx over dt, which is 0.01. So 0.01 times 1200 would give me 12. So dv over dt would be 12 centimeter per minute, or 12. Okay.